Okay, let's go over this Unit 2 review. Number 1, if a line rises to the left, its slope is negative. So that means if the line rises to the left, it looks something like that. That is negative slope. Okay, number 2 says, what's the slope of a line that is perpendicular to the graph of y equals 2x plus 5? So remember, the slope is the number in front of the x. So the slope of this line is 2, or 2 over 1. If I want to find the perpendicular slope, I want the opposite reciprocal. So I flip this fraction over, and then I switch the sign. So it becomes something that was positive to something that was negative. And negative 1/2 is our answer. That is the opposite reciprocal to 2 over 1. Flip, switch. Okay, number 3. What is the slope of a line that's parallel to the graph of 2x minus 3y equals 6? Well, you need to put this in slope-intercept form first. So we subtract the 2x from both sides. We divide everything by negative 3. Once we do that, we get this equation, y equals 2/3 x minus 2. And then I know that the slope is 2/3, because that's the number in front of the x. And if you ever want to know about parallel slope, you want the same slope, because parallel lines never touch, which means their incline is the same, their slope is the same. So if this line has a slope of 2/3, a line parallel to it also has to have a slope of 2/3. So if lines are parallel, they have the same slope. If lines are perpendicular, their slopes are opposite reciprocals. Flip one of the fractions over, switch its sign, and you get the perpendicular slope. All right, number 4. This one requires us to use our slope formula, y2 minus y1 over x2 minus x1. And so you just have to remember which ones are your x's and your y's. And so it's 0 minus a negative 1, which becomes 0 plus 1, over 14 minus 7. And when you work that out, you get a slope of 1/7. Number 5 is just like that. Same formula, finding slope between 2 points. So 7 minus negative 4, which becomes a plus, divided by negative 3 minus 6. And when you work that out, you get 11 over negative 9. But we tend not to leave that negative in the denominator, so you could write that as a negative 11 over 9, or you could write it with the negative out in front. They all three mean the same thing. We just typically don't leave the negative in the denominator. Okay, number 6 says find the slope of the line graphed below. When you're given a graph and you want to find the slope, then we count our rise over our run. So I have to see where it looks like the line goes through corners of boxes, and it looks like it goes through a corner right here, and it looks like it goes through a corner right here. So you can see it rises 1, 2, and it runs 1, 2, 3. So slope is rise over run, so the answer is 2/3. Okay, number 7. Write an equation in slope-intercept form for the line that has a slope of 2 and passes through 1, negative 5. Okay, if I give you a point, we are going to use what's called point-slope form, which looks like this. And if I give you the point and the slope, then you're ready to go. So it just goes y minus the y-coordinate, so y minus negative 5, equals the slope 2, and then in parentheses x minus the x-coordinate, so x minus 1. The next thing you would do is distribute that 2, and then in order to get y by itself, you would have to subtract 5 from both sides. And if you subtract 5 from both sides, you will get this answer of y equals 2x minus 7. So if you ever want to write an equation of a line and you're given a point, we're going to use what's called point-slope form. And you're ready to use point-slope form if you have a point and a slope, which we did here. We had the point and the slope, so we were ready to use it. Okay, number 8. This one we want to write an equation of a line that's parallel to this line here. So if it's going to be parallel, it's got to have the same slope. So if this line has a slope of -2, the parallel line has to have a slope of -2. So that's the slope we want to use, is -2. And then we want the line to go through the point 0, 1. So once again, I have a point and a slope, so I'm ready right now for my point slope form. So y minus the y coordinate equals slope x minus the x coordinate. I distribute the -2. I get rid of my -1 by adding 1 to both sides. And I get my final answer of y equals -2x plus 1. What do you think about this point slope form? Okay, number 9, another writing an equation. We want the slope-intercept form of an equation of the line, but this time we want the line to be perpendicular to this line. So I figure out what my slope is, which is a -3/2. The perpendicular slope will be the opposite reciprocal, so we flip the fraction over and we switch the sign, and that gives us a positive 2/3. And then we want the line to go through the point 3, -2. So I've got my point, I've got my slope, and I'm ready for point slope form. So here it is. So I know you're thinking, fraction, but this one's easy. 2/3 times x, 2/3 x. 2/3 times a -3, that's a -2. And so then to get y by itself, I would just subtract 2 from both sides, and I would get my final answer of y equals 2/3 x minus 4. Okay, we're going to move on to number 10. I was afraid maybe some of those numbers were a little too light for you, so I'm hoping you were able to see them. And in case you weren't, I am just going to hold it here for a little bit so you can see the work on 7, 8, and 9, just in case some of those numbers were too light for you to read. So when you're writing equations of a line, if they give you a point, point slope form is the one you want to use. And as long as you have your point and your slope, you're ready to go. And then with 8 and 9, you just had to remember that if lines are parallel, they have the same slope. So that's why I worked with the slope of -2, just like this one had a slope of -2. And if you work with perpendicular slope, you want the opposite reciprocal. So you flip it over and you switch the sign, and you get the positive 2/3. Okay, and just showing you these for a second in case you need to see them again. All right, moving on. Number 10, we start getting into midpoint. So we're going to use our midpoint formula, which is where you add your x's and divide by 2, and you add your y's and you divide by 2. So as long as you remember that the first numbers are the x's, you're going to add those together, and then hopefully you remember that the second numbers are the y's, and you'll add those together and divide by 2. And you should get an answer of 6, 9/2. If you wanted to change this to 4.5, you could, but there's nothing wrong with this improper fraction as long as it's reduced. Okay, number 11. This one requires us to use the distance formula. So if you ever have 2 points and you want to find the distance between them, we follow this formula. So you just subtract the x's, get that answer and square it. Subtract the y's, get that answer and square it. And so that's exactly what happened here. We subtracted the x's, we're going to square it. We subtracted the y's, and we're going to square that. And you end up with 6 squared, which is 36, and -5 squared, which is 25. And if you add 36 and 25, you get the square root of 61. Now, if we wanted to know a decimal equivalent to that, then I am just going to put the square root of 61 in my calculator. So I hit the second and the x squared button, square root of 61, and I can see that it's about 7.8, and that's if we round to the nearest tenths. So about 7.8. So just so we have practice with both of those answers. Okay, number 12. This time we want to write an equation in slope-intercept form. So anytime you have a diagonal line, you're going to put your equation in slope-intercept form. In order to do that, you only need to know two pieces of information, the slope and the y-intercept. So I need to count my rise and run. So once again, it looks like it goes through corners of boxes here and here. So I rise 2, I run 3, so that's my slope, which you see here. And then B stands for the y-intercept. Where does the graph cross the y-axis? And the graph crosses the y-axis right there. So that's our y-intercept, which has a value of -2. So once you know your M and your B, you just plug them in. So I put 2/3 where the M is, I put -2 where the B is, I just recopy the x, the equals, and y. And now I have the equation of this line in slope-intercept form. Y equals 2/3 x minus 2. Okay, number 13. We're back to writing equations from words. So this time we know the slope is -1 and it goes through the point -4, 3. Once again, I have a point, so we're going to use point slope form. And did they tell us the slope? Yes, they did. The slope's -1, so we're ready to rock and roll. Y minus the y coordinate equals slope, x minus the x coordinate. I distribute the -1. And then to get y by itself, I add 3 to both sides. And my final answer is y equals -x minus 1. Okay, number 14. Writing an equation of a line again. This time, I want the line to be parallel to this equation here. So in order to figure out the slope of this, I have to put it in slope-intercept form. So first, to get y by itself, I subtract the 9x. And then to get rid of the 3, I divide both sides by 3. Once I reduce that answer down, I can see my slope is the number in front of the x, which is -3. And if I want to be parallel to that, then I need to be working with a slope of -3 as well. Okay, so -3 will be the slope I want, since I want the parallel slope. I want to go through the point 5, 3, and so I'm ready for point slope form. And then when you work that out, you should get an answer of y equals -3x plus 18. It's just the same stuff over and over again. They give you a point, point slope form. You want a line parallel, you want the same slope. It's just if they give you an equation that's not in slope-intercept form, then you have to put it in slope-intercept form first. That way you'll know that the slope is the number in front of the x. Okay, number 15. Same thing, writing an equation of a line, but this time we want to be perpendicular to this line. So I have to put this in slope-intercept form to know what my slope is. So to get the y by itself, first you subtract the 4x. And then to make this a positive y, you have to divide both sides by -1, which gives you y equals 4x plus 12. So this line has a slope of 4. If I want the perpendicular slope, I have to flip this fraction over and switch the sign. Remember, 4 is understood to be over a 1, so when I flip it over and switch the sign, I get a -1/4. So that's my perpendicular slope that I want to use. And I want to take it through the point 8, 2. So y minus the y coordinate, which is 2, equals -1/4, the perpendicular slope, and then x minus the x coordinate, which is 8, and then I distribute. Now notice every time you keep getting these fraction slopes, that when you distribute, you end up getting a nice little number back behind that x. And then the final answer you should get is y equals -1/4 x plus 4. Hopefully you remember all this stuff from Algebra 1, so hopefully this is easy peasy. Okay, number 16. Back to finding midpoint. This is just like number 10. So when you want to find midpoint, you just add your x's, divide by 2, add your y's, divide by 2, reduce if you can ever reduce, and you should get 3/2, 1. So midpoint's super easy. It's just finding the average. Add your x's, divide by 2, add your y's, divide by 2. Okay, number 17, this is like number 11. We want to find the distance between those 2 points. So this is where you subtract your x's. So 4 minus -7, which makes a plus. Then you subtract your y's, -6 minus 3. And then you work out the numbers in the parentheses. 4 plus 7 is 11. -6 minus 3 is -9. Then you square. 11 squared is 121. -9 squared, -9 times -9 is 81. And then you can add these two numbers up, and you get the square root of 202. And if we want a decimal equivalent of that, I go second, the x squared button, type in my 202, and the square root of 202, rounded to the nearest tenth, is about 14.2. Okay, number 18. This one wants us to find the distance from point D to line T, shown in the figure. So if I want to find that distance, the closest distance D is away from line T is from here to here. So if I were to identify those ordered pairs, this point is 1, 3, and this one right here is the point 3, 2. And then I just use my distance formula. I subtract my x's, square that, plus subtract my y's, square that. I work it out, and I get the square root of 5. And just to get a decimal equivalent of that, the square root of 5 is about 2.2 if we round to the nearest tenth. So to find the distance from point D to point T, I really kind of want to know the closest distance they are. So not from here to here, but from here to here. Just identify what those ordered pairs are, and then just use your formula. Okay, another video will show you the rest of the review answers. I'm going to stop this one for now.